Hello everyone and welcome back to this third week of the second module. In this week we will keep working on our car scene and we'll add some exploding pieces with custom velocities from the ground. Also, we'll add some debris on them, which will be driven by a pop network using an art-directed technique. Before starting, we are going to add a couple of nodes that will help us to get some nice interior detail to these pieces. If you guys try to use it to get some detail on the high-res pieces, you will notice that probably wasn't working. As I say, this method requires an inside group to work. And if you middle click this node, you'll see that we didn't have any. That's because we didn't turn on this create interior surfaces option here. And neither we have any inside group after this first fracture. So let me open a new scene of this where I have everything fixed, and I'm gonna explain you what I've done. So after the extrude volume node here, I want everything but the outside group to be inside one, to be the inside one. So let's do it by using a group combine sub node. So I'm gonna create a new group called inside, and this group is gonna be everything but the outside one. We can test if this is working properly with blasting some piece. So if I look closer, I can press S and 9, and now I have the inside and outside group. Besides, let's go to the second Voronoi and let's grab some piece with some fractures. Not this one, but let me single pass this. Let me see if this has subfractures. Perfect. First, if I explode view this, we didn't have these interior faces, and that's because, as I said, we didn't turn on the create interior surfaces. So after do this, we can do another thing. We can call this new interior group as inside sub. If we want to optimize by having a different name to these faces, we could do that. So if I highlight the groups here, I will see that now we have an inside group, the inside subgroup, and the outside one. This should be enough for the RBD interior detail sub to work properly, but unfortunately I couldn't make this work as I intended. So pay attention here. So if I hook a RBD interior detail to the end of the loop, let's cook this first. I don't need the visualization. So if I plug a RBD interior detail here and I blast some piece, this is gonna work properly. But as soon as I want to tweak the parameters, I can realize this is not a fast workflow. For example, let's pump up the noise amplitude. So this is working fine, but it's taking a while to compute because it has to apply this node to every piece and then I blast them. So the proper workflow should be to blast one piece first, and then apply the interior detail. So we can extrapolate to all pieces. But as soon as I do it this way, I can see something wrong. And I'm pretty sure this is a bug because I do still have the groups I need. Of course, I tried to apply this method inside the for each loop, but it still wasn't working. So let's hope they fix this in future versions. And for now, I will save these high-res pieces with interior detail again. So let's connect the output of the interior detail here. I no longer need the visualization. And let's save this again. Now, if I go here and I blast a piece, after unpacking, here we go. Alright, so the goal of this week is to make our pieces collide with some geometry once they are activated, and generate some debris from the collisions. We'll use some kind of underground worm as a static object, so let's go ahead and create it. First, let's create a new geonode, call it collision ground, and let's dive inside. And I want the animation curve. I want to import the animation curve. So I don't think I have any null node here, so let's create it. I think it's located in the crack geometry, and I want this curve. So let's drop down a null. Let's call it curve animation. Go back to our object merge, and now let's drag this. If I turn on the point visualization, you can see that we have to sort this properly. So let's drop down a sort node, and I want this to be reversed. I want the point sort to be reversed. Now let's say I want to keep the first 50 points, so let's call a blast and set this to points. And to keep the first 50, we have to type 0 to 50. Press enter. Non-selected. And here we go. Good. Let me drop down a polywire node. And here you can see I can grow or shrink the radius with this parameter. I can also add more divisions. The trick is that we can drag this radius with an attribute for each point. So let's do it with a point bob. Drop it here, dive inside. And first, I would like to fit all these 50 points from 0 to 1, depending on their number. So let's take the PT_num and divide it by the number of points. So I have to divide the PT_num by the number of points. And it's a good practice to bind export temporarily attribute in order to cast our operation somewhere. So let's do it by this attribute, and let's call it underscore temp from value. The underscore is useful if you have plenty of attributes on the spreadsheet and you want this one to be the first one. As you can see, it looks like it's not working, and it's because we are working with integers. So let's make them into float. Integer to float. Duplicate it. And here we go. That looks better. But if I sort these values, it's not giving me 0 to 1 values. And this is because the number of points is giving us the total point numbers. But remember that if the bigger point number is 50, it means that we have 51 points, since it's counting from 0. So let's subtract constant 1 unit before converting it to float. That looks better. Cool. So let's now plug this result into a RAM parameter, which always needs a 0 to 1 input. And let's visualize this color. Let's go back. And here I can change these values. And definitely this is working as expected. So now I want to create a new width attribute from this. So let's change this type of ramp to spline. And let's bind export width attribute. Maybe let's append a multiply node before it and promote this value, just in case the radius is too low. I don't need this or this. Let's jump back. Let's set this to 1. And let's play with the RAM values. It's not changing the shape of the polywire because we have to type the attribute we created here. So it's called add width. Cool. Let's now make a worm shape kind of. Maybe I want to change this to Bezier curves. And let's create new points. Something like this. Yeah, this should do it. Maybe more divisions. Cool. Next, I want this to be barely below the surface. So let's transform it. And I'm gonna need the crack as a ghost object. So let's display the surface. Let's go back to the worm creation. Set this to ghost. Gonna need the front view. And let's load this value. Something like this will work. Yeah. And now I will finish by manually setting this guy to a static object. So I'm gonna clean the attributes first. I don't need this one, this one, this one. And on one hand, I'm gonna set this to collision geo. And on the other hand, I had to convert this to a BDB. So let's do it by BDB from polygons. Because we are gonna use BDB SDF as collision geometry. This resolution should be good. So let's out this as collision BDB. Great. Let's jump now into the sim round.network, and I'm going to add a new static object, merge it with the main simulation. This is going to be our worm, collision worm. So let's call on the subpath the geometry node. So let's drag this here. I need this to be deforming geometry since it does have animation, and this option could be useful to have better collisions, more accurate. But be careful because it can be expensive to compute. Now we have to call our BDB by going to the collisions tab and drag the collision BDB here in proxy volume. And this is very important. You have to set this mode to volume sample. Let's see if we have the worm already loaded. Give it some frames. And here it is. Let's see the collision guide. And this will have exactly the same resolution as we set in the sub level. So this is not changing the resolution. Cool. Let's go to the first frame. Set the output here. Change the collision guide to display geometry. And let's give it a go. Nice. Maybe too explosive. So I would like to quickly add some drag forces to it. So let's drop down a pop drag. And since we are using a rigid body solver, we don't need to add a multi-solver to use this pop node with the rigid body ones. So let's turn on the vex expression because I want to add some variation on the drag, and I will do it by typing. Let's first create our seed. This is a temporarily variable, and this will be theta1 random of ID plus some seed, maybe 0.1 to 0.5, and then I have to multiply this value by the seed. So let's see how is this value called. It's called air resist. So let's call it by air resist multiply times seed, semicolon, and let's bypass this to see the difference. This is the first simulation without the drag. And this is the one with the drag. Yeah, that's much better. If we are not sure if this is working, let's pump up this value and you'll see it's definitely working. So let's go back to 1. And now we are ready to go ahead and talk about the breeze. So let's create, as usual, a new geo node. Below the geo tab, call it the breeze, dive inside. And I would like to go over it by introducing you this useful node called .import records. With this node, you can have access to some data in some simulation. For example, if I call the sim round, this one, and I type impacts here and here, I will get a point for every impact recorded. Let's see if this is working by hitting play. And what you are seeing here is every impact within the DOP network. I want to get the ones near to our collision geometry only, so let's call our worm. Here. Okay, let's paint the worm as white. And let's paint the import records as black. Now let's attribute transfer the color. I will transfer only the color, and I need to change the threshold. Let's template the worm. Maybe something like this. And let's blast our black points by blast. And you can either blast red, blue, or green channel. I'm going to blast the red one by typing @cd.r less than 0.5. We need to set this to points. Cool. Now let's create more points by using a PDV from particles node. Set this to density. Lower the radius, maybe something like this. And I will scatter some points to these voxels. So let's drop down a scatter node. Turn off relaxed iterations to go faster. And I'm going to use by density. Let's leave it by default because I want to have 2 layers of debris coming from the collision, and the one of them is going to be bigger than the other. So the smaller will have a lot of more points. It will be nice if they start with certain velocity, because right now they only have the position attribute. So I'm going to take the velocity from the pieces. So let's call them using a DOP network. Sorry, a DOP import node. Let's call the ground simulation. Set this to fetch geometry from DOP network. And I want to see them as points. So let's drop down a pack edit node and change the display as centroid. I don't need to see the static ones. So let's delete by using a expression. Here I can either use the X, Y, or Z component of the velocity. So I want to delete the ones which 0 velocity. So let's type @b.x, for example, equals 0. Now if I set this to point, here we go. Let's finish this by transfer the velocity to the new points by attribute transfer. The velocity. And now I can see the velocity vectors by control middle clicking here and clicking the V. Perfect. So let's output this as in medium debris. Since we're going to create a second layer of debris later. So let's now jump to object level and create a new network. Call it sim medium debris. And we need this to be a pop simulation. So let's call pop source, pop object, pop solver. We need gravity. Let's merge this together. And let's set the soft path to our medium debris. So they are located here. Let's drag this here. Set this to all points. Let's see if this is being called properly. Okay. Let's go back. And I'm gonna add some extra velocity to them. I would like to add some variance. This is fine, maybe lower. But I would like to add more velocity upwards. So let's set this to, for example, 2. Cool. I'm going to add a ground plane here. Merge it. And remember, the ground plane should be placed at 7 units above. Let's go again. Cool. I don't need neither bounce or lower friction. So let's change this by going to pop object, physical tab, set the bounce to 0 and the friction to 1. Let's play again. Yeah, that should do it. Now finally, let's add a little bit of drag by dropping down a pop track again. Actually, I can copy paste the one I have on the ground sim. So I'm gonna copy and paste it here. Let's see if these values are working fine. Yeah. Cool. Remember that we are using the ID to random because it will be the same throughout all the simulation. So let's leave all the other nodes by default, and now we can just create the same workflow with the small debris. So let's go here. I'm gonna press L to sort this properly, and let's just duplicate this network. I'm gonna call this as small, and this time I will change the density scale because I need more debris here. So let's set this to 150. Okay. Let's create a new network. call it small debris, dive inside, and I have to change the path of this to small debris. And I think the same values will work. Let's hit play. Maybe let's set this small debris more aggressive by lowering down the drag. Maybe by half. Okay, so now we can create the render geo from this layer. So let's call it render debris, and I need two .import nodes. First one is going to call the small debris, the second one the medium one. So let's do it by typing sim medium ones. I only need the pop object. I don't want to import the ground plane, so let's type pop here between stars. Let's fetch geometry from the network. Here we go. Let's call it import medium debris. Duplicate this. Import small debris and change it to small debris. Okay, now I can maybe merge them. Give to each one a different color. For example, medium will be red and small will be blue. Let's see how it looks. And if we are happy, we can create the presets that we will randomly instance on these particles. So I will drop, let's say, a box. And this time, since I only need to fracture this as quick as possible, I will do it with a RVD material fracture. Maybe let's add more scatter points here. Let's see if this is what we want. Correct. So now we have for each piece to move it to the centroid, to move each piece to the origin in order to avoid any offset when we have to copy it to the point. And then we will pack them. So let's do it by using our for each name primitive. And first, you have to check if you're using this method that you have the name attribute on the primitives. This node already created for us, so this is going to work. So let's grab a piece. Let's fetch a transfer node. We can call the preset we have to move the centroid to the center here. And oh, I think there is a typo here. So let's change this first value to the correct one. And I want to override this preset. So let's save again. Call it, I think it was called centroid. Okay. Now we have to type the following here. We have to move this to the origin. So let's do it by saying channel px minus channel py I minus channel pz. Okay, now I have to pack them. And here we go. Let's maybe scale this pieces to, let's say, 0.3. And now let's instance some random pieces on the risk point by using two methods. Firstly, I will show you how to use the old copy stamp method, and then we will do it by a for each method. But this time you will see the benefits of compiling it, and hopefully we'll reach computing times 2 or 3 times faster. Let's start with the medium debris. And first, both methods, copy stamp and for each compiled, one needs an ID for each point. But the one we already have, this one, is not useful because we need an ID which goes from 0 to the total number of pieces we have, 75. And this will allow us to randomly assign random pieces of the total number of pieces we have to instance to each point. So let's add a wrangle, and I'm going to type the following. I'm going to first create a random number for each point. This is creating a temporary variable. It means that it's not casting this variable to our spreadsheet. So I'm going to need the total amount of pieces we have here. So I'm going to plug this into the second input. And let's call this by integer number of points equals to this function number endpoints of the second input. If I want to check if this is taking the value properly, I can do it by creating an attribute here, and I'm gonna add the underscore to make it go to the first line. So let's say underscore empties equals empties. And here we go. Cool. Let's comment this. And now we have to overwrite our ID attribute by this one, which is going to be fit01 of random, which is this random value. And it's going to go from 0 to the total number of points we have on the second input, which is NPTS. Let's see if this is working. Perfect. This is a warning it's giving to us because it's implicitly casting from float to integer. We can get rid of this by converting this to integer by typing between parentheses int. This is the same as the float to integer in PointBob. As you can see, we don't have any numbers greater than 74. But actually we need the 75, so let's add a unit here. Perfect. So now let's drop down, we'll start with the copy stamp method. So let's drop down a copy stamp node. And first, input the pieces, the primitives, and the points on the second. Now let's create a new variable. Remember to turn on this checkbox here, and it's going to be called ID. And since this ID attribute already has the variation that we want. We just need to call it. So let's add ID. Now, you can see that this is copying all the incoming geo to every point. So we have to delete everything but one with this ID stamp. So let's do it by calling a blast node. And I want to call this stamp variable by tapping here between quotes, stamp. Let's call the node, copy one. The variable is called ID. And we need 0. Close the quote. Set these 2 points. Set not selected. And here we go. Cool. Now let's go to the first frame. And I would like to check the frames per second. So maybe let's turn off the real-time toggle. Hit play. I think this is some viewport issues. So I'm gonna save the scene just in case. I'm gonna close this viewport. And I'm gonna create a new one by pressing Alt-1. Let's set this as we had. Perfect. Now let's hit play. Let's center the camera in a better position. And take a look at the frames per second. Not bad, but it could be better. So let's go ahead and start with the compiled for each node. This method is a bit advanced, but I'm pretty sure you will understand it. The trick is to use the new compile blocks, which allow the for each loop to run in parallel, spreading the iterations across multiple cores. So not all the nodes are compilables, and you can find which ones are not by going to the network display options by typing D. Let's go here to batches and let's set the non-compilable sub-batch to large. The ones with the icon are not compilable, at least on this version of Houdini. Another thing to keep in mind is you may have to go over another solutions when you have to get to the iteration number. There's plenty of information if you go to the Houdini documentations of this compile nodes. Maybe if you check the end compile. Yeah. Spend some time reading this. So let's start by calling a for each node. Let me organize this better. Okay. This is the copy stamp method. Now let's call for each node, and I want to go for each point I have here. So this time I need the for each point. Let's drop down and copy 2 points and set the points to copy to this point and the primitive to the end of this for each. The workflow is similar, so let's call a blast node. And I want to blast all the pieces but the one who has the same ID attribute as this iteration. So we have the ID attribute on the point tab. This one is 34. So since this is a point attribute, we have to call by using the point expression. So let's set this to points, let non-selected, and let's type within quotes point of for each begin to. This is the point 0. The attribute is called ID 0. And this should work. Here we go. Actually, let me test by deleting this 0. I don't know if this is going to work without it. No, we need the 0. Okay. Now let's finish this by plugging this to the for each end. And we should pack this. No, sorry, it's already packed. Okay, so let's go to the first frame. Let's compare the compute velocities of this. You can see that this is running quite slow as well. So now let's take a deep breath and let's call a compile shop. Okay, so an easy way to understand is you have to imagine this as levels. We must create an entry door for each input that affects the outcome. So first, we can add our begin node here and the end node here. Let's set display to this value and make sure the for each end is multi-threaded. So as you can see, there is a warning here. And it looks that we need more inputs. So let's create a new one by selecting this compile begin and create block begin node. Let's set it here. And still complaining. Remember what I told you about levels? We're jumping one step here. So I need to go from the compile to the for each and then to the blast node. So let's go to the for each begin, and I can call a new entry by creating a meta import node. But this time, I don't want this to affect the loop. So I just want to set this to fetch input. Now let's grab this new for each begin and set it here. Let's see if this is working. It's not complaining. Let's hit play. And it's complaining again. Let's see what it says. It looks like the problem is that we are trying to internally referencing a compile node in the blast node. So to go ahead this problem, we need to reference the block begin node or any metadata node by using a spur input instead of typing the expression here, the path here. So let's do it by clicking here and let's add a spur input. Now I want to call this for each begin. So let's just drag this to here. And What this description says about the spare inputs is that you can refer it by using -1 on the expression. If I had more, then we will be named it as -1, -2, etc. So let's just switch this path to -1. And yeah, finally it's working. Let's compare now the velocities. Cool. It's much faster. Let's finish this with another example. Let's say I would like to add some random uniform scale to all of these pieces. So using the same kind of method, I would like you guys to pause the video and give it a try. So basically, we have to use a transfer node and set random values based on our ID. But remember that we can't internally call a compile node. So let's drop down this here. Let's drop again a spare input. Drag this here. And let's type our expression on the uniform scale parameter, which it's going to be theta1 of random of this value. I want to randomize this ID value. Let me. I should have an ID. ID. So for each point, what's happening here? PD. Maybe if I disable the compile nodes. Okay. It looks like I can go over the attribute when I have the compile nodes. So what I was saying is I need to go over this value and randomize it. So let's turn on again the compile method, turn on transfer node, and I'm gonna call this point attribute by typing point of -1, which is the spare input, and again the point 0, ID attribute, and 0. Close the two parentheses, and let's say I'll go to 0, 50, 15 to 4. Cool. Let's bypass this to compare. Maybe less. And this is working properly. Okay, so this is the end of the third week. You have learned a lot of new stuff and techniques here, so I will leave to you to do the same method with the small debris. From now on, you should keep in mind that all these kind of problems should be solved using a for each compile method. Because nowadays is how they work on a production project, since it forces all the cores of your CPU to work together. If you want to go one step further, I highly recommend you to take a look at this Houdini masterclass here. I hope you guys enjoyed this week and see you in the next one. Hi guys, just a quick and interesting tip before ending this week. I want you to take a second and compare these two outputs. The first one is using the compile for each method we had. So let's hit play and take a look at the frames per second. Now let's see the second one. Amazing, right? And they are using the same variation, as you can see if I jump from one to another. What have I done? Actually, it's not rocket science, but you have to understand that it's not the same if you're looping for among 100 points than 10,000. So a better way to do this would be doing the same, but this time working on pieces. Let me show you the new workflow. First, instead of doing a for each particle, I'm going to take all the pieces and assign them a new ID attribute, and I'm going to work for each piece. So I'm taking a piece. This wrangle could be outside. The transformer node goes in the end, and what I'm doing is actually blasting the particles by the piece ID. So this is calling this node is taking this one attribute, and I'm gonna blast as non-selected as much points as they have the same piece ID. This one is number 74. So then I copy this piece to these points. I give them a little bit of variation on the scale. And then if I end this with the for each end and the compile end, this is gonna go way more faster. Look at the FPS. Cool. I hope you enjoyed this, and again, see you in the next week.